Yeah, thanks again for joining the session. So this is going to be, though it's dis, Gaurav described it as a talk, but I want this to be as a discussion because that's how I arranged the topics. So basically, it is my attempt to persuade to use Go in your next project if you're not already using it. So let's see how that attempt goes. But in the discussion, I'm not going to show you any Go code or discuss any of the Go features in details or even demo any code. Probably that we can do in the future session. First of all, Go. I strongly believe Go is a very simple language that you can get the basics in a day time and probably get comfortable with the language itself in a week time and be productive in a month time. So you can definitely learn Go by yourself, but we also have plan to add a beginner level session in the future Golang meetup. But then what is this session is all about is it is basically to motivate you to try out to Go or just to explore Go and see what Go can provide you so that you can use it in your next project. So let's begin. Okay, now my keyboard. Okay, so before we start, let me give you a brief intro about me. So I've been writing Go for the last 6 years. I started, I think, between 2015 or 2016. I don't remember, but that was my very first backend system that I was developing, designing, and developing, and I started writing Go at that time. Before that, I was predominantly in C, C++. Was basically an embedded C++ engineer. I worked in Python, .NET, and Java for a brief time. So my experiences, professional experience as well as Go experiences, are mostly around system software or system programming. Though I have done some bit of uh, backend development in a conventional say, but it's predominantly on the system software like IoT and edge devices. So yeah, so the reason I want to highlight this is I can definitely contrast Go with other language like C, C++ well, but my experience with the Java or even DOS .NET is limited. So if I say something is not available or doable in Java or .NET, and if that is incorrect, please feel free to interrupt me and correct me. Okay, so we will begin with why Go. I mean, why Go was created in the first place. Uh, we all know Go was created by
You
Google.
can share your screen. Sorry.
Sorry,
You could share your screen.
my screen is shared.
Yeah,
Gaurav.
I
Oh, I'm
could
so
see his screen, Gaurav. I can see your screen.
Gaurav, you're not able to see my screen?
um I think it's an issue on my end. Sorry.
Okay, okay. So yeah, so Google created Go to address their own problem. This was way back in 2007. So they have code bases. They had code bases in C++, Python, and Java, and they were facing numerous challenges with those code bases. Some of them are intrinsic to the language or the technology itself. Some of them are the engineering problem. To start with the technological or language limitations. So if you take C++, C++ is a highly performant language and it allows you to write object-oriented code, but it is not an easy language to start with. Then to write a good C++ code take years of experience. So there are people with years of experience, but they make a basic mistake and the program end up crashing at the production the deployment. So that's on the one hand. Then they also use Python. As you know, Python is a highly productive language, and it's friendly language too. It comes with a lot of standard modules or packages. Then there is a wide, vibrant community, so you can be super productive with Python. But the thing is, it is not as performant as C++ or Java because it is an interpreted language, and on top of that, the language has its own challenge like a GIL, so that didn't allow the Python program to execute as performant as the Java or C++. Then they were also writing Java, so it was kind of a middle ground between C++ and Python, in a way that Java is a compiled language, so it is certainly faster than Python, and it is also relatively more productive, friendly language than C++. But Java has its own limitation. One is the huge on a large code base. The compilation itself takes it will take a lot of time, and loading a Java program takes time, and the memory consumption is really high. Um, so those were the challenges they were encountering with the language themselves. Then on the engineering management, it was a big or it took long for a Google engineer, for a new Google engineer to be productive because of these language choices. So if the new engineer going to contribute a C++ code base, then he or she need to learn the language and be proficient in the language, know in and out of how the pointer works and all the nuances of the language before they can be productive in that language. And the same goes for Java. And so the other challenge with their code base was their code bases were really huge, and it took them long to compile and release it. So the entire release cycle was slowed down because of the compilation time. So I know in C++ they were using a cluster compiler to speed up the compilation process. They might have utilized something similar for Java as well for all the compiled languages. And one another problem they were facing that is specific to Java was it is limited to certain platform, at least at that time. So they had a variety of hardware platform where they want to run their application, but to run a Java program or even Python for that matter, you need the underlying runtime to be available for the target platform. Let's say you have a PowerPC machine, then the JVM and Python interpreter need to be have to be ported for that platform before you are able to run the uh, application on those hardware platform. At least C++, you can cross compile those programs for any platform, because usually the platform toolchains are written in C or C++, but it is not an easy thing. So uh, that is another challenge they were facing. And to address all this, um, people at Google, mainly three of them, Ken Thompson, Rob Pike, and Robert Grace. Each of them are known for their own contribution to the technology world, like the Unix, Plan9, operating system, and Java hotspot. They got together and they started designing a language in 2007, and it was publicly announced in 2009. The very first version, stable version, was released in 2012, and the latest version is 1.16, which was released in February 2021. Okay, so we looked at the history and how it started when it was released. Now let's see, what is this language? I mean, what is the property or characteristics of this language? So to start with, Golang is a compiled language like a Java or C++ or even a C# or .NET. So the program gets compiled, needs to be compiled for you to run the program, and to compare it against with non-compiled language like Python and Ruby, this certainly provides certain performance improvement because the runtime doesn't need to parse and understand the instruction at the time of execution. Rather, it can do it at the earliest time, and it can also catch syntactic errors or other language-specific errors at the compilation stage itself. Whereas to achieve a similar thing in a non-compiled language like Python Node.js, you have to have a comprehensive unit test so that all parts of your implementation is exercised before you deploy the application in the production environment. Then Go is a statically typed language. So you need to specify the type of the data that you manipulate in a Go programming. This is again similar to Java, C++, or .NET languages. But to compare with a non-dynamic type language or a duck typing language like Python, the language infers the type from the data, and this can lead to issues or errors at runtime if the implementation is not comprehensively unit tested, because you might be storing your data, you might be storing an integer to a variable in one place, but down the line, the same variable, we might be storing a string, and the other part of the code, if it tries to manipulate it as an integer, then that will fail. So to catch these kind of errors in a non-compiled or a dynamic type language, we need to have a extensive unit test, whereas in a compiled and statically typed language, this comes free. It is done at the time of the compilation. And Go is a concurrent language, highly concurrent language, in my opinion. So it allows you to write code and execute them concurrently. And in doing so, it also, in fact, I would say concurrent and parallel, because it also allows us to utilize all CPUs or CPU cores of our underlying hardware. This is not always true in the modern programming languages. If you take Node.js, which is based on an event loop and limited to a single CPU core. So to utilize all the CPU cores of the hardware, people usually run multiple instances of a Node.js application so that all CPU cores are utilized. That proves that it is doable, but the problem is then you need to decide how do you want to manage your application level caching, because all these are individual processes. You cannot easily share the data. So you need to come up with the IPC mechanism or other way to exchange data between these processes. So all those are avoided in a language like a Go, where the concurrency, it utilizes all the hardware, all the CPUs of the underlying hardware. Then goes a garbage collector language like a Java, .NET. But the highlight is, at least in my experience, I never witnessed the well-known GC pass that people easily observe in a Java program. So I never noticed GC passes in the Go program that I have written. Maybe my code didn't allocate or manage a large amount of data, but at least I didn't observe, or in my friend circle, I never heard about this problem. But this is quite common in a Java programming, any large-scale Java program. As part of the first level optimization, they'll look at how long it takes to do the GC, and what objects can be pulled, what can be allocated freely, and all those things. So this Go GC is certainly better, far better. And Go is a cross-platform language. So you can write a program that you can write a Go program that can run in Intel architecture, ARM architecture, or a PowerPC architecture, and it supports wide variety of target architecture. But the best thing with Go, and it is one of my favorite, is ability to cross compile your application. So if you may be developing, you may be writing the Go program on a Windows platform, but if your deployment environment is a Linux, you can actually compile, build the binary for the Linux environment on a Windows platform. And you can do vice versa. And you can do it for a Mac, and from Mac, you can do it for Windows and Linux. This is really exciting for me because as an embedded developer, and whenever you are working with the edge or IoT device, which may be running on a different architecture or a different platform itself, you want to quickly compile a program or fix, change something and quickly generate the binary and copy it to the target platform and run it, see how it works. Otherwise, if it requires a separate environment to compile it for a different architecture or a platform, then it will impact your overall troubleshooting cycle, because every time you have to switch to the environment and wait. But Go does it like breeze. It's really cool. Then Go compiler, not just the compiler, but the entire tool chain is blazing fast. In fact, it is one of their USB. I couldn't find any metrics for this over the internet. So what I did is I cloned Prometheus, which is written in Go, Prometheus code base, GitHub from GitHub on my local machine. And I built it, and it just took 3 minutes to build 120,000 of lines of code, and a warm build took only 3 seconds. So 120K is definitely a large number, but it's able to build it in under 3 minutes, and a warm build is, which is what we frequently do, it just takes 3 seconds. Now, if imagine this with a similar size application with a Java, I seen taking minutes, I mean like 15 minutes, 30 minutes time of time. And C++, so C++ library, I built a Boost library, which is a large code base that took, that usually takes hours, 1 or 2 hours, depending on our host OS, but minimum at least it will compile it for an hour. So, but Go is really fast, so it improves your development lifecycle. And Go is an open source language, though it was designed by people working for Google, but the community kind of adapted it now. It is fully driven by open source community, whether it is a change to the language or a bug fix, everything is discussed in GitHub forum discussion boards, and people upvote or downvote, then a final decision is taken, then it gets implemented in the next release. And Go is a highly opinionated language, simple language, fun as well as boring. So opinionated in the sense, Go prescribes a certain way of doing things. So that you will realize that when you start writing a Go program. It could be even as simple as, where do you want to put your curly braces of a code block, whether in the same block starting or in a separate line. Go is a simple language because there is usually everything is explicit. I mean, if you're handling error, you clearly see code that handles the error. If something happening, you can be sure that I can find at least one line of code that indicates that it is doing something. So it is simple, and it prefers explicit over implicit way of doing things. It is fun language because of all these features. It's I find it really fun to work in Go. Ever since I started writing Go, Go become my if I to standard for trying out things. If I want to, let's say, try out a experiment, I'll pick Go as the language. But at the same time, it is also boring because lack of generics or lack of other things. At times, you may be duplicating code. In fact, Go encourages the code duplication to reduce the complexity. So they advocate that if the code duplication makes the code simpler, helps the future reader to understand better, please do. So at times, because of the principle, you can see that there are a lot of places where the implementation might be repeated, and it is okay. But for a new person, it might be boring when they manually repeat that code block. Okay, and it got just 25 keywords. So that's why I mentioned that you can learn the basics in a day, and you can be comfortable, be productive in a week. And in a month time, you'll be like enjoying the language like over time. Okay, so before we move, any questions till now? I take that as a no and move on. Okay, let's look at some of the language features at the high level. The Go toolchain, whether it's a compiler or a refactoring tools, everything is highly optimized, and that's why it is able to achieve such a blazing fast compilation or a development cycle. And Go comes with a rich set of standard library. So I'm not even talking about third-party packages. What I'm talking is the standard functionalities, standard packages, utilities. That is more than enough in most of the cases. So with just Go installed, you can write a API handler, you can write a backend service. You don't need anything else. But if you are I mean, if you don't like repeating a code, if you don't like repeating things, at the time you look for some external package that simplifies some of the uh, redundant things or redundant code. So, but otherwise,
Hi, I think we are facing some technical difficulty. Not sure if Siva's internet got dropped. Just give it a couple of minutes. Probably he'll be joining back. Can you hear me?
Yeah, I can hear you. We'll wait.
please, you are able to hear me?
Hey, Siva, you're back. Yep, we can hear you now. Let me make you the host again.
Yes, please. Yeah, I need. Sorry about it. It is a power failure.
Oh, shucks. Yeah.
My router, yeah, didn't have a battery backup, so. Okay, now let me
make you the host somehow. Yeah. Okay. Yep, you're the host now. Over to you.
Okay, I hope you are able to see my screen now. Okay, so we were talking about standard library and what Go provides out of the box. But that just not that the Go is usually compared with Python when it comes to the third party or the external libraries, or people even say it comes with batteries included, like how they say for Python. Uh, Whether you want to, whatever that you want to do, you can find yeah, external package for it. Sometimes you'll find a very good implementation, matured implementation, whether it could be parsing a protocol, network level thing, or it could be connecting with some esoteric database or anything. You can find a library in a Go community. Sometimes the library might not be matured. I mean, for example, in YAML, there are a lot of attempts going on. There are a lot of interesting projects. Go packages provide something similar to a Python, NumPy, or other packages. But I think, in my opinion, they are not yet mature. Though I haven't used it, but what I heard from people, it is not yet mature. There is a lot of development going on those areas. And so the Go next is Go way of handling a program failure or error is through error handling. This could be different for people who are familiar with the exception handling way of handling the program errors. But Go decided to go with this for the reason that I mentioned. Everything need to be, Go prefers explicitness over implicitness. So if there is a error handling code, you clearly know that the program can fail it at this point, and what kind of a error it can return, and whether that error is handled or not. So all of this you can understand just by looking at the code. Whereas if it is an exception handling, first of all, you need to, I mean, if it is a large function, you need to find out where is the catch block, and if it is even if the catch block is catching all the possible exception, it is not easy to figure out exactly which function call going to throw this particular exception. So this is one of the reason, at least in my opinion, why uh, error handling in exception-based language is not that mature or not that great. Whereas in Go, as well as I also seen this in Rust, it is very clear that what exactly you are dealing with, what is expected, whether you are handling the expected or not. So that's why Go chose with error handling. And Go passes the parameters by value as well as reference, or you can also understand as a pass by pointer. So there are places where you can pass the parameters as it is, and they are passed, they are copied and passed to the calling function. But if it is, let's say, a huge struct which you don't want to copy or avoid the copy, then you can pass that by reference. Or if you want to make changes to the struct, you can pass by reference. And Go provides built-in mechanism for unit testing, benchmarking, package management, code generation, and embedding static data. So this is, though this might look like no, I'm not going to use it, but trust me, you will really enjoy the unit test and writing unit test for Go programming, because it provides such a tight integration, and even benchmark. You can easily find out how long a function takes and how many allocation happens when a function is called. And these are going to be really helpful when you start troubleshooting non-functional issues like the performance issues in the production environment. Because once you have these functions, or even if you don't have these functions, but you implemented, your implementation is just collection of function, it's just easy for you to write a benchmark or unit test for the function and quickly measure what is the performance of that particular function. And the package management is again part of the tool chain. So it went through various iterations. So originally there wasn't a provision. Then a lot of external tools like Go PKG and I think Glide and quite a lot of attempt or external tools were created. Then at one point, Go, I think they had this vendor approach. Then recently, they finally settled on a module-based approach. So it's been stable, I think, since 1.15. And now the entire community is adapted the mechanism, and it is quite easy. I mean, everything is part of the tool chain, so you don't feel like you are interacting with some external tool. And code generation, this is quite useful. Yeah, let's say you have a gRPC based API, or you have a protocol buffer that you exchange between application or a machine. You don't need I mean, you usually, as part of build process, you usually run the uh, protocol serializer or deserializer to generate the code for a specific language. In this case, Go. So you have to execute the protocol command line tool and specify specify the specification file, then the language and output directory, and this has to be done as part of the build cycle. Now, this you can specify in Go, you can specify this in the source code itself. So when you look at the code, you clearly know that, okay, this code is generated, and the generation happens because it is specified here. So again, this makes the entire development cycle, it's fully integrated one. You don't end up interacting with multiple tools for different functionalities. Um, then the final one is embedding static data. So there are a variety of use case for this. If you have your SQL migration, you can embed those SQL migration within your program, so that you don't need to ship those SQL files separately or place it in the same directory. Or let's say you want to write a standalone executable that provides your website that runs a website, and you want to include all the web assets. You can include all the web assets as static data as part of your program. Or let's say it could be your certificate or any static data you can include in your program. So the inclusion of static data is not something new. It is supported by almost all languages, whether Java, C++, or any language. But the way how it is done in Go is amazing. You specify, you declare a variable, then you say this variable should hold the data of this static file, and you run this command to populate this variable. And at the compile time, the compiler takes care of converting that file on your file system into a static data, and connects that variable with the static data, so that you can just access the variable. So any code that you write, you can just use the variable, and at runtime you'll get the static data. Okay, so let's see some of the specialities of Go. The first one is Go routine. Go routine is the way people achieve concurrency in Go. But what differentiate Go routines from threads is it is extremely lightweight. It is called lightweight thread or a green threads, and it is fully managed by the Go runtime, not the OS. So if you whether it's a .NET, Java, or C++, the thread you create is actually there is a one-to-one mapping between the Java thread and the OS thread. So there is only certain amount of thread you can create, and the thread switching actually involves a syscall. It has to talk to the OS, or the OS initiate the switching. And that includes a overhead. And so that's a reason why you cannot have so many threads, because the OS will run out of memory, your process will run out of memory. And even if, let's say, you have some hundreds or thousands of threads, the switching overhead will nullify any advantage that you get by running so many threads. But as the go routines are managed by the runtime, the overhead of Go routine is negligible. It is, I think, it even starts with a 2K stack and it can grow, but the switching happens by the runtime, not by the OS. And there is a YAML mapping between Go routine and OS thread. So there could be thousands of Go routines mapped to, let's say, 4 OS thread. But it is quite common to see Go program running with thousands, if not hundreds of thousands Go routines running behind the screen. This is especially true in a web backend application where each request is handled by a separate Go routine. And if your web service is serving thousands or hundreds of thousands of requests, then each of them will spawn a new Go routine, but that will not uh, have any overhead on the program. Of course, it will have overhead, but not to the level of OS thread. And channels are the communication mechanism between Go routines. So you want to achieve concurrency or you want to do parallelism, you write your code as a Go routine and spawn the code. But how do these Go routine communicate to each other? So in other languages, you might have used IPC mechanism, shared memory, or variety of ways you can communicate. But the prescribed as well as the standard way to do that in Go is channels. So channel is like a pipe. So you send some data from one side, the other side will receive it, and both the side can run independently. You can make the endpoint or the consumer or the producer to block or non-blocking communication. So there are variety of ways you can use the channels to achieve communicating between the Go routine. So this heavily inspired or based on the actor model or a CSP. I think it is in Erlang, I believe, if I'm right, Erlang or Elixir. And Go also provides named return values and multiple return values. Both are also possible with some of the modern languages like Kotlin and REST. But Go also provides that, just to highlight it. And this will be quite useful. You cannot achieve or Go couldn't have achieved a error handling based error mechanism if the multiple return value wasn't there. So you can, if you look at any code base, you can always see the functions will have minimum of 2 return values. One is the error, the other one is the actual result or output of the function. And the named return values are just a convenience. Will come handy in certain cases, but not always. Okay, so before we move on, any questions? I cannot see the chat window, so if you have a question, please unmute and ask. Okay, I take that as a no, then. Okay, let's see. I mean, we've seen what Go provides, what Go has. Let's see what it doesn't have. Go, to start with, Go is not an object-oriented programming language. Go allows you to reuse code and achieve data encapsulation, but it is definitely not a object-oriented programming language, though you can achieve some of the object-oriented programming properties, but not in the conventional way, like how it is done in a Java or a C# or even C++. So you don't have a class inheritance or type hierarchy in Go. And Go for a long time, or even till now, doesn't have a generics. So the designer uh, uh, didn't feel that there is a need for a generic, and they highly encourage code to be duplicated. So this is where the code duplication comes. So if you have a sorting algorithm that operates on an integer, but you want to apply, you want to do the same, use the same algorithm for a on string, the way you do that in Go is duplicate the code. But then the designers heard the community feedback and they realized the value of or the need of the generic in certain unique case. So now the proposal is accepted and it is getting developed and it will be available as part of our version 2. So there will be, I think it will have a backward incompatible change. So that's why it is available only in version 2, major update. Go does not provide traits or mixins, and Go does not allow pointer arithmetic that we can do in C++ or C, where we can take a pointer, array pointer, and increment the pointer by, let's say, 2 and skip 2 elements. So these are not possible, but you can still achieve the same with the slices. There can be underlying array, but you can limit the view of the array using a slice. And Go does not support implicit conversion. So all conversion have to be explicit. You need to specify how to convert and what happens if the conversion fails. You need to provide error handling for that. Go does not support method or function overloading. So you can see functions with word like with or some annotation just to differentiate that the same function with the context or some additional parameter. So that's because of this not providing a function overloading. So the reason why Go does not provide function overloading is again to go with explicitness. So if there is a function, but you have 10 different overloading, it's very confusing which function will be called. And it is even more confusing if one of the parameter can be implicitly converted to other type, but you have a overloaded function for both the type. So all these are happened. I mean, you can see such a code in C++. So that's why Go decided not to support function or method overloading. And exception handling, we already discussed the way you handle program errors using a error handling, not
Shiva, I have a small doubt here in terms of exception handling. So when we talk about generics and stuff like this, right? One thing is exception. If generics are there, then exception handling is fairly easier to handle. And on the same side, we have stack unwinding, and then we have exception unwinding, wherein if we have a nested amount of functions which are being called, and at the nth order level, a function is throwing an exception. We have to explicitly handle these errors across the entire stack of functions, and then so how do you see it compared to modern languages like Rust, or at least in C++, it's like very well handled. But so do you see that as a huge disadvantage in Go?
No, actually, having used exception handling in C++, I really see this in a positive way, in fact, a productive way. So, I mean, in the past, let's say there is a third-party package or external library that you use, and that library has multiple functions. And if there is an error or exception in the innermost function, and if the error if the public facing function of the third party library did not handle the error, convert to a proper understandable format, understandable way, then you will end up having an exception that you'll have no idea about it. So it could be some strange exception. You don't know why it is coming, but all you know is you called a external library and it is throwing, and you have no idea how to handle it, and sometimes it may not even convey what needs to be taken or what failed. So in that way, I feel Go as well as even Rest doesn't have exception handling. I like them because if you are returning a certain error, the language forces you to handle it by the immediate caller. So your error cannot escape from the immediate caller, because all the immediate callers are forced to handle errors. So you have to handle it. Even if the immediate caller does not understand, they need to wrap it or package the error in certain way so that the calling function or the application layer understands them. So I certainly feel this is a plus for, I like this way of handling program errors in Go and as well as Rest.
From a discussion standpoint, I could understand that, but when we have these FFIs, right, this foreign function, like what we use, like CGO and stuff like that. So from that sense, the stack unwinding right from the CGO layer to the Go layer was not, I felt that it was not very well handled, but I'm not sure. I mean, just as a point of discussion, I just made that part.
Okay. So I'm not sure in C does not support exception. So if you are referring a C++ code, that is it is really hard to have a proper unwinding with a C++ code, because the ABI application binary interface is not standardized. So if you, let's say you have one library SO file, or that is compiled with a GCC one version, GCC version, let's say 3, another library that is compiled with the GCC version 4. Even those two are not compatible, because a particular exception might occupy, let's say, 16 bytes in GCC version 3, and the same struct might occupy more bytes in a latest GCC version, because the STL might change. So as far as I know, there is no safe way to handle this by the calling application. So that's why if you look at a C++ application, even if it is consumed by another C application or a C program, they always wrap with a C function and basically flatten, basically convert the exception, catch all the exception, convert that into a error code and pass it to the application layer.
Got it. Yeah.
Yeah. So that's why I feel this is not really a weakness, more I think it's I see this as a strength. It makes us to handle all possible scenarios or failure scenarios.
Cool.
But probably there is a case that I'm not seeing. We can discuss offline. We can discuss in our also.
Thanks, sure.
Definitely. One thing to add on that front, even though Go does not have exceptions, it does have panics. So you do have a poor man's implementation of exceptions in Go. But having said that, errors are definitely superior. They lead to less spaghetti code. Like you don't have this exception handling somewhere very far off than the cause of the exception itself. So with Go, you tend to have that error handling upfront. You tend to have that error handling in the place where the error itself occurred. So that leads to much more readable, much less confusing code, in my opinion.
Yeah, makes sense.
Okay. Sorry, guys, I just realized the time, so I'm going to speed up from here. So I think I have a few more slides. Let's see. see the use cases of Go, so is not best suited, at least for a large scale, high performance distributed, let's say a CLI program or OS guarantee that it will do certain action, it will execute certain things at the precise time. But it still be more productive because of the rich ecosystem and performance and ability to cross compile. I'll highly recommend Go for system programming if it is not a real-time system. So Go is not suited for real-time systems like audio-video playback or even high frequency trading. Because even a millisecond in those system, millisecond delay might have a bigger impact. And though Go's GC pass is not observable to us humans, but it might still steal a couple of milliseconds in your execution, and that may have a consequence on real-time systems. So it's not suitable for real-time systems. And for AI and ML systems, I am not recommending because of the immaturity of the ecosystem. Because though there is time to time there are packages popping up that trying to be compete Python, NumLive, or other packages, but I don't think they are mature because it will fizzle out.
Not able to hear Shiva. Gaurav, is this the same case for you, or is it the connection from my side?
What?
I'm not able to hear Shiva.
I think it's your end, Srini. Now it's proper. Like earlier, I wasn't able to hear Shiva properly, but now it's proper.
Okay.
Yeah, but he just to add on, yeah, Srini, Shiva is leading onto your talk really well. Like with this point, like Go is not suited for AI ML is what Shiva claims. So I think it leads well itself to your next talk.
Yeah. So I think I can have some rebuttals there here and there.
Sure. Okay. Moving on. So there's just some screenshot from TAOB. As you can see, it was announced in 2009, kind of touched at around 2015, 2016. That's when I started writing Go. A lot of people adapted Go, and it touched up another peak. It was language of the year for 2009 and 16. Other stats that you can find in TOD site. So this is where Go sits when you compare Go with other languages. So on the left side, there's the left diagram shows the efficiency was beautiful or straightforward code. So certainly C++ sits slightly above of readability. So I don't have experience in Finland, so I cannot comment on that. But I don't know why they put Python and Ruby on the this lower side for the beautiful. I mean, so there is not there are a lot of magic happening in Ruby, so maybe that's why they put it there. So on the right side diagram, it's for fast for humans and fast for computers. Again, you can see Go is kind of plays a middle role. It is really fast for the machine as well as humans, but not as fast as for the machines like C++. At the same time, not as productive as like a Ruby or a Python.
The left graph is extremely biased, especially with closure up on top.
Okay, so yeah,
like beautiful straight code closure. Yeah, no, I don't think so.
Closure is like a different programming paradigm itself. It's data as code. So
yeah, I didn't think that's beautiful. I didn't think even closure developers would claim closure code is super beautiful or anything. It's succinct, but it's hard to
actually from a compiler standpoint, like designing compilers in closure is like much easier because
Much,
the
easier.
data itself is code.
Okay.
Yeah.
That's true. Sorry, Siva.
Okay. Sorry, guys. You are breaking for me because I'm connected on a 4G connection. But did I? I mean, I don't know whether you asked any question.
No,
No
Shiva, we
question.
were just discussing on the closure stuff. That's all.
Okay. Okay. Let me move on. So for performance, I found an interesting Medium article that I linked in the bottom. I showed the link. So it's I did not take any so this guy, he wrote a web application. It's a backend application implementing 3 APIs. Then he ran implemented it in Java, Go, and Rest, and he did a performance test on the 3 implementation. And this is the memory consumption and the number of requests each of them can able to achieve. Or tops, Go comes second, but I'll still make a compromise with the Go because of the readability and simplicity compared to rest. Okay, moving on. So I just showed up a sample program. I mean, I just want to give a very high level or a taste of a Go program. So this Go program implements a
Hey Shiva, your voice is fading in and out. I think now like your network connection.
connected. Are you able to hear me now?
Now we are. I am at least able to hear, but before it was breaking.
Srinivas, you are able to hear me?
Yes, I'm able to hear you now, Shiva.
Okay, thank you. Okay. Okay. So this is just a simple web, not a web. So this is just a is implementing your route. Um, and if you visit localhost 8080, whatever you give after the route path, after the as a path, it will say hello and whatever path, whatever that you've given in the path. So if you look at the code, we are not using any of the external package. We are only using what is provided by the Go standard libraries or packages. And everything is, as you can see, probably less than 15 lines. If you exclude the import, it is even less than that. So this is the simplicity, this is the productivity that you can achieve with a Go program. Some of the notable projects which you may be already using, like Docker, Kubernetes, Terraform, and Prometheus. And there are many more. You can find these on the Wikipedia. And some of the notable users are GitLab, Heroku, Netflix, Cloudflare, and even ThoughtWorks. Recent time they started using Go. Java was their preferred language, but they started implementing their solutions in Go. And these are the learning resources. So you can visit these links for further understanding of Go, or if you want to seriously learn Go and start using it. And that's pretty much it. I'll share the feedback form link in the chat. But yeah, if you have any question, we can discuss now. No questions? Okay,
I guess
then.
it was super. Thanks, Siva. Thanks for your talk. It was really well.